Okay, good morning. This is Professor David J. De Los Reyes. It's October 31, 2023, and the time is around 3:46 a.m. Okay, my topic for this session will be a continuation of my long video format discussion. It's a complete syllabus on trigonometry, and I am now on lesson number 15. We are running smooth. The concentration of the subject matter for the last three sessions is actually angle measurements, uh, angle of angle of depression, angle of elevation, and the application of the bearing. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 15. The title of the topic will be an example problem on angle of depression, okay, with an additional thing bearing. The last time around, I had bring out the concept on how to plot the bearing of a point or a line as seen from above. Okay, so in this problem, I will be consolidating the concepts of the so-called angle of depression and bearing. Okay, let's proceed. I didn't write the verbal problem on the board, but I give you the specification of the problem, so I will make a verbal explanation of the problem. Example. We are given bolt number 1. This is bolt number 1. The angle of depression is 32.6 degrees. Okay. The bearing is north, 70.4 east. So we are given a boat. It's in the water surface. And the angle of depression of this boat, we are given a tower. The tower is this one here. The height of this tower is 380.5 feet. And from the top of this tower, it was determined that the angle of depression with respect to the horizontal going down is how much? 32.6 degrees. This is 32.6 degrees. So with respect to the tower observation point, they took the reading of the angle of depression of boat number 1, and it came out to be 32.6 degrees. Okay? Actually, the water surface is this one. This is the tower, this is the observer, this is the boat. And what come out on the angle of depression is 32.6 degrees. So actually, we could bring out one right triangle. This is the water surface, and this is the tower. The water surface is assumed to be horizontal, the tower is assumed to be vertical. So the angle between the water surface and the vertical thing is 90 degrees. So this is boat number 1. The angle of depression is 32.6 degrees. Okay, that's the storytelling for boat number 1. And what is this bearing here? The significance of this bearing here is something like this. If you are on an airplane and you try to take the top view of the ocean, okay, there will be this is the direction of the compass, north, this is south, this is west, this is east. According to the given condition, the bearing of boat number 1 is actually, what is a bearing? It is an angle emanating from the north or south direction, and it will go to the east or west direction. And according to the given problem, the bearing of boat number 1 is north, 70.4 degrees east. So if we try to plot that one, if this is north, bearing is an angle that emanates from either the north or south direction, and either it will go north or east or west. But for the given problem, the bearing is actually north, 70.4 going to the east. So this is 70.4. What's the significance of this? The tower knows exactly the location of the boat with this given bearing. That's why in the so-called naval warfare, okay, it's a must that the computer things they are using over there should indicate a bearing for any incoming, what they call this, enemy warship or other things, right? So the importance of this bearing here is to determine the exact location of boat number one. And the exact location of this boat number one is with respect to the north, it goes 70.4 degrees. This is the reference line, right? It goes 70.4 degrees. So if we try to draw a line over here, that's the boat. Okay? That's the boat. Okay, we'll continue the verbal explanation. For boat number 2, we are given boat number 2. There are two boats. This is boat number 1, this is boat number 2. For boat number 2, the angle of depression is 16.9 degrees. The bearing is south, 19.6 degrees east. Okay, let's plot first the bearing. The bearing is south, 19.6 degrees east. As from the definition of a bearing, it could either be north as reference point or south as reference point. But for this boat number 2, it is south. So meaning to say, if we try to bring out the bearing of this, the reference point of boat number 2 will be south. And it goes 19.6 degrees east. This is east, so it seems they are on the first and second quadrant. So this is 19.6 degrees. Okay? So with respect to what they call this tower, okay, they could actually determine the exact location. The exact location of this boat number 2. It is with reference to the bottom of the tower. It is 19.6 degrees deep. So actually they could pinpoint the exact location of this boat. Right? So 19.6 degrees. This is 70.4 degrees. Okay? Oh, that's the importance of the bearing. So don't ask me where you use the bearing north 70.4 and south 19.6. This 70.4 is this one, and the 19.6 is this one, as seen from above. So this is top view, right? So it seems you are given a right triangle, you try to view it from top, and the triangle that will come out will be this one. It is this side here plus this side plus the distance between the both. Okay, as seen from a top view. Okay, the problem is asking what will be S equal to the distance between the boats. So with these given conditions, okay, boat number 1 is here, this is the bearing. Boat number 2 is here, this is the bearing. The angle of depression of boat number 1 with respect to the height of the tower is 32.6 degrees. I forgot, the bearing, the angle of depression of boat number 2 is angle of depression 16.9 degrees. This is the tower, this is boat number 2, the angle of depression of boat number 2 is 16.9 degrees. Okay? So it's actually further, you know, the angle is lesser than the 32 point something. Okay. This is the water surface, this is boat number 2, this is the tower. The water surface is horizontal, the tower should be vertical, so the angle between this side here and this side should be 90 degrees. The angle of depression is 16.9, so if this is 16.9, this should also be 16.9. Okay? The problem is asking what's the distance between the boats. The solution is just an easy one. The only problem is how we imagine what will be the required figure. So there are actually 3 figures here. You try to imagine that you are viewing from a top view, so you could actually visualize where the boats are with respect to the bottom of the tower. And view number 2 is actually this is a vertical line, this is the water surface, so there should be a 90 degree over here. So if we try to bring out the right triangle considering boat number 1, it will be something like this. It is this. The distance of the boat with respect to the bottom of the tower is, I represent this as y. y. First boat. The second boat, its distance from the bottom of the tower, I represent it as x. So there are actually right triangles. For the first boat, there is a right triangle. For the second boat, there is a second right triangle. Because from the right triangles, we will derive the equations on how to compute for the distance s. Okay, let's try to bring up the solution. We'll bring out the right triangle of boat number 1, okay, considering the angle of depression. As seen from this observer here, this is the observer. The angle of depression of this one is 32.6 degrees. Okay? So if this is 32.6, this is also 32.6. This is the height of the tower, this is the water surface. So I designated that the distance of the boat from the bottom of the tower is y, so this is y. So in here, actually we could compute for y now. Right? We are given this angle because if the angle of depression is 32.6, this should also be 32.6. So we are given this side, we are given this angle, and this is unknown for the meantime, so, but we could compute for it. By using one of the definitions of trigonometric functions, the relation of this one with respect to this, considering this angle, this is opposite side, this is adjacent. So tangent is opposite over adjacent. Tangent 32.6 will be 380.5 over y. And we can compute for y. Y is 595 feet. So on the given problem, y is actually 595 feet. The distance of the boat with respect to the bottom of the tower, if the angle of depression is 32.6 degrees. Okay, easy. For boat number 2, there is also a right triangle. Considering this vertical line and this water surface, this is also 90 degrees, right? This one. It's isometric view. So if we try to bring out this vertical line, it is this. The horizontal line will be the distance of the boat from the bottom of the tower. It will be x. This is x. The angle of depression, according to the problem, is 16.9. As seen from the observer, the angle of depression of this one is 16.9. It's this. So if this is 16.9, am I still on the camera? This should also be 16.9. So again, we are given a right triangle in which the vertical side is the height of the tower, 380.5. And the horizontal distance represents the water surface. The distance from the bottom of the tower to the boat number 2, it will be x. So actually, we are also given one angle, one side, and we are looking for x. And again, the relation of x and this one is tangent. Considering 16.9, this is opposite, this is adjacent. So taking the tangent of this one, it will be 380.5 over x, and we could compute for x. X now will be 1252 feet. Okay, so this is 1252 feet. It's further, yeah, right? 1252 feet. Because the angle of depression is smaller, right? So again, if we try to bring out the resulting right triangle, we bring out the third right triangle as seen from a top view. This should be one side, this is another side, and the hypotenuse will be the distance between both number 1 and number 2. Okay, how come I know that the angle between x and y is 90 degrees? Okay, you try to take the sum of 70.4 plus 19.6, that's 90, right? So one half revolution is actually 180, right? So 180 minus 90, luckily, right? The angle between y and x is 90 degrees. So what comes out is this one, this right triangle here. Okay? You got a right triangle as seen from above. This is y, this is x, this is boat number 2, this is boat number 1. So the distance between the boats is actually this side here. It's this. So we are given y. We have computed already for the value of x. Okay. we know exactly that the angle between y and x is 90 because 70.4 plus 19.6 is 90. So 90 plus 90 will be 181 complete revolution. So this is 90 degrees to be exact. So what we are discussing here is a right triangle. Supposing this is 91 degrees, we could not use the Pythagoras principle. Okay? But since this is 90 degrees, we could compute for the value of x and y using Pythagoras principle. Right? So computing for the value of s, Pythagoras principle. The square root of the hypotenuse will be equal to the square root of x plus the square root of y. If we try to compute for s, right, it will be the square root of x plus the square root of y, then take the square root. And the value of s is 1,386 feet. So the distance between the boats is 1,386 feet. Okay, that's it, guys. I think this is a very interesting problem, and it involves the concepts of angle of depression and bearing. Okay. Good morning from Los Angeles. This is Professor David J.